Let me move this one. Okay. So thank you everyone for attending. Right now I'm at home, so my home internet is not very stable. So if the video sometimes might not be very smooth, but you can always let me know if there's something goes wrong. And so I send the link in the Slack channel and also the chat box. You can check out the Jupyter notebook example we are going to go through in this workshop. And you can click the link, or you can directly go to the website leafmap.org, and then on the left side, click workshops, and you should be able to see the SIG Special 2021. And once you click here, you should see this notebook. It's rendered as a website, but you are welcome to click the link upper right corner here. There's a button to download the notebook to your computer. So once you download, you can download to any directory. You can also directly click open in Google Colab or Jupyter Binder. So up to you. And I would like to point out that Jupyter Notebook has some, Google Colab has some limitations. So not all the functionality works very well in Google Colab. Recommend that you try out Binder, but the downside about Binder is sometimes it takes a while, maybe a couple minutes to actually load up. So I recommend that you just click the link, maybe right click, and then open the link in a new tab. So it might take 1 to 2 minutes to load up. If it doesn't work, you can always open in Google Colab. So I have set up everything, make sure that it's reproducible. So you should be able to come back to this notebook later if you want. So, and let me go back here. So first, I would like to quickly introduce Leafmap. It's a package that I developed, I think, started in May 2021. So it's just 5-6 months old, and I have added a lot of functionality as still being actively developed. So you're welcome to, for example, check out the GitHub repository. You can click the upper right corner here to go to the GitHub repository. And you can see it has almost 1,000 stars so far. And if you have any questions, for example, today you can always ask questions in the Zoom or Slack channel. But later on, if you want to ask questions, you can go to GitHub and then discussions. So from here, you can ask all kinds of questions about the package. If you have any specific, find any bugs or you have any feature requests, you're also welcome to submit through GitHub. So next, let me come back to the repository. So essentially, it's a open source package for interactive mapping and geospatial analysis. So let me give you an analogy, right? Right now, we have all kinds of, for example, platform that you can write document. For example, Google document, Microsoft Office, desktop version, Microsoft 365, right? We have all kinds of software, and the interface all look very different. And sometimes people have to learn multiple software. So what I'm trying to do here actually is to build on top of multiple mapping libraries and to provide or simplify the same API so that you just need to learn one package and then you can use most of the functionality provided by those packages. But one thing to keep in mind is that not all the packages provide the same functionality. So there's some slight differences in some of the functions, but you're always welcome to check out the documentation. And so you can also check out the API reference, some of the modules that already have, and you can click the link, for example, and from there, you should be able to, for example, click the function and you should be able to see all the source code. So everything is open source. You're welcome to inspect the source code and also contribute to the package if you want to. And so next, let me come back to this notebook here. And again, you can open in Colab or Binder. The second one is Jupyter Lab, and the last one is Jupyter Notebook. So you can use either one that you want. So for the Jupyter Notebook and Jupyter Lab, I already set up the environment. So you should be able to open and then directly run through all the source code. But if you are using Google Colab, I have a first few code blocks here, teach you, for example, how to actually install all the dependencies that you can going to be used in this notebook. So you can just run through each one. You should be able to get started. Okay, so that's kind of brief introduction. And for today, I'm going to go through some of the key features. This is just some key components. There are a lot more features. If you want to learn more, you can go to the Leafmap documentation. So I have each individual feature as one notebook example. So you can go to the link, and then so every notebook example has a node collect and Jupyter icon that you can open, and everything is interactive. So you can, for example, play zoom in and zoom out. All right, so let's get started. So first, the first section is for those using Google Colab. So I'm just going to skip this one. You just want to install all the dependencies. You can also set up the environment on your computer. So because Leafmap depends on GeoPandas, and GeoPandas sometimes can be challenging to install on some computers. So I don't include GeoPandas as a required dependency, but you can optionally install this one and then install the packages. So you just copy and paste this to the command line. You should be able to install everything. And once you have installed the package, then you can create some interactive map. Leafmap has right now so far have five protein backend. Basically, you just need to import the library. For example, import a specific module, and then all the remaining code remain the same. So, for example, I can use Leafmap, Leafmap. So Leafmap is the default protein backend. So basically, once you import the Leafmap, then you just leafmap.map, and you can create a map, and this map is interactive. And it also comes with a lot of interactive components. For example, on the right here, there's a toolbar icon. So you can click the toolbar, and then you should be able to use this. So we're going to cover some of those later, but just let you know, the Leafmap protein backend has the most functionality. Other protein backend, they have relatively limited, but most of the codes still look pretty much the same. For example, if you import the folium module, and just the first line is different, everything else remains the same. So I can create a similar interactive map using folium. So there are lots of mapping libraries out there, but some of those have some similar functionality. And the next one here is Capital GL. So this one has some 3D functionality. And again, you can just create a simple interactive map like this. The last one is PyTech. So let me show you here. And right now, just a simple base map, but you can add data. You can basically integrate more data into the web app so that you have more functionality you can do with the map. And so by default, you can just use the protein backend to create a different base map. But if you want to customize, for example, I can just by default is using the US, the center around the US, but you can certainly, let me create this one here. So center around the US, but you can change the latitude and longitude and also the zoom level. So for example, I can customize, and then you can change to a different location. So this is, you can use that to create a default map. You can also customize the size. For example, I can do width and height. So you can easily customize this one. And this one here, by default, again, is using the Leafmap protein backend with some interactive GUI here. And if you think it's too crowded, you can certainly customize the control. For example, some of the control you want to turn on and off, it's up to you. So everything is easily customizable. For example, right now, the dual control and the measurement control has been disabled, and the full screen, right? So you can, everything is flexible and customizable. If you don't want any controls, you can just clear all the controls. And so right now, just a simple base map without anything, any data layers, without any control. The second one here is about changing the base map. We have tons of internet web map services available on the internet. So if you use Leafmap, you can bring in all kinds of data layers without having to actually download data to a computer. So in this case, you just need to pass in an argument. For example, I want the terrain base map. I want some Google map. You can use just using one line of code. You can directly, when you create a map, you can pass in the argument, or you can just use add base map. So either way, you can create the map that you want. You customize the default base map. So the Leafmap has a bunch of default base map. As you can see from here, it has over 200 base maps. So you can choose any base map that you like. And this is a long list. So the last one I'm going to show you here is that you can also use the interactive GUI to add base map. So for example, in this case, if you can click the toolbar upper right corner here, and then click the first icon. So this one will allow you to change the base map. For example, I can change to row map, or you might need to turn this layer off. So this one here, upper right corner, let me turn off this one first. So this here, this one is the first icon is just a toolbar. So if you click, it's going to be dock layer. But if you unclick, it's going to be just when you hover your mouse, it's going to show you. So the second one here is the layer. So you can turn the layer on and off. For example, this is the Google Map, right? By default, it has the OpenStreetMap. So you can turn the layer on and off. You can do this for all the data layer. As long as you can add the data layer to the map, you will be able to turn it on and off, right? So next, let me go back here. This is the base map icon. So once you click the map, you will be able to select from all kind of base map from here. So over 200 base map that you can choose from. For example, I can open maybe open topo map, right? I think it's here, the second one. So open topo map, and for example, Esri map. Oops. So it might sometimes might be a little bit. Let me see here. Let me uncheck this one. From the beginning. So for example, OpenStreetMap, satellite, Google Satellite, NLCD, for example. So there are a lot of things you can choose from, and you are welcome to explore, see which one you like. Besides seeing this, you can also click this icon. For example, you can search all kind of base map available on the internet. So once you click the icon, I can, for example, I can search, they say Esri, and just hit enter. It will search the available XYZ type services or the quick map services. For example, once you search, then I can just simply click whatever base map you like. It's going to load the map directly to the base map. So save you tons of time. My goal is to make it easier for people to use. So even those with limited programming skills, they can still use some interactive mapping. And so, for example, you can also check the box, quick map services. So that one has thousands of web map services you can use. For example, I can just search Google, and it's going to show you what kind of base map that has the Google keyword. Then I can, for example, select Google Satellite Hybrid. And this one might take a couple seconds because it's just retrieving the URL and then load the data to the map. So makes it easy. If you're interested in specific base map, you're always welcome to use this to source the base map. All right, so that's about how to create a base map and create a map and then add some base map. But you're also welcome to add any tile layer services, for example, XYZ tile services. All right, so this one actually is just the tile XYZ tile URL to the Google Satellite. So you can just directly add the data layer to the map. If you have other web services, you just use one line of code, then you can load the data to the map. You can also use a WMS tile layer, and this one here is adding the US net imagery. And sometimes maybe if the URL is down, you might not see the data layer, but it should be adding here. So today it looks like the URL is not working, but if you have other URL, you can just change the customize this, and then should be able to add WMS. You can also use the XY services provider. So this is a new package that I think just developed during the last couple of months. And so I incorporate this one. Basically utilize over 200 base map available. And then so you basically use whatever through this, all the web map services through this package, and then can directly load it into the map. Besides the base map, you can also add all kind of cloud optimized GeoTIFF. For example, if you have a URL to the cloud optimized GeoTIFF, you're welcome to check out the link here. Some of those are from MaxR, the WoV2 imagery. So for example, this is before and after the fire, and you have the URL hosted somewhere in the cloud optimized GeoTIFF format. Then you can just use the add code layer and should be able to load the data directly to the map. So as you can see, right, you don't have to download the data. And this data, this cloud optimized GeoTIFF, you can actually use for analysis. You can access the data, you can load the data, you can also see the changes. For example, this is the fire happening here in California. And you can zoom in, you can see the imagery before and after, right? So you can easily load this kind of data to the map without having to physically download the data. Besides the cloud optimized GeoTIFF, DIFF may also support stack, so spatial temporal asset catalog. So it's kind of a similar to the cloud optimized GeoTIFF function. You can, if you have the file hosted on the Geojson, you can actually query and then get the data. And you can also customize what kind of a spectral bands you want to show on the map. So again, everything is interactive. You can load the data. Besides cloud optimized GeoTIFF, Leafmap also allows you to load the data from the local drive. For example, if you have some GeoTIFF on your computer, in this case, I'm going to download 2 example files from my Google Drive, and then I can create the interactive map, and then I can also load the data. So essentially, Leafmap can load local data. It can also load data hosted in the cloud. So it can also load base map. So there are all kind of things you can do using Leafmap to basically you can combine multiple data layers to show on the same map. This one might take a couple seconds. You will see here is spinning. Sometimes it will take maybe a couple seconds to load up, but we can come back to this one later if it comes up. Okay, so once you have the data, sometimes if you have some, for example, land use, land cover classification, and then you have the data shown on the map, you might want to add a legend or something. So Leafmap allows you to easily add some legend, for example, land use, land cover, or some other data set. For example, in this case, it's the NLCD, right? So you can add this kind of legend to the map easily. The NLCD is built in, so you just need one line of code to add the data layer, add the legend to the map. But you can also use some customized one. So for example, let me show you this one here, right? You can define the legend as a dictionary. So for example, here I add the WMS layer, the NLCD, and then I define a dictionary, a key, and also the color. And you can change this one to whatever you want, and just one line of code, you can add the legend to the map. So this is very easy to do. Besides the legend, right? This is discrete. But if you sometimes you want some color map or color bar, Leafmap also support it. So it has a color maps module. For example, some common one, you can create a palette, for example, digital elevation or NDVI or something like that. So you can easily, for example, you can change the value, you can customize in all kind of way. You can also customize how many classes you want, right? And then once you have the data, here we show you a couple examples, right? It can be continuous. It can also be discrete. You can also change the direction, so orientation, for example, to be vertical, right? And then once we have those, you can easily, again, use one line of code to add the color map to the map. So I create the map, and then I add the base map, for example, in this case, open topo map. And then I can add a color map. So you just need to pass a keyword. This one is called terrain, and then has this, the label, elevation, width and height, and also orientation, and also the minimum maximum. So very easy to do, just one line of code. If you want it to be vertical, you can do it vertically like this. So in that way, your data has some meaning. Otherwise, people have to guess like what those value actually, what the color actually represent. And so Leafmap has all the matplotlib color maps available. So it depends on what color map you are interested in. You can easily, so all this in here. So you just need to pick up the name of the color map, and then you can pass into the function to this one here. It should be able to add the color map for you. So in that way, it saves you tons of time having to do all the coding manually. All right, so that's about the adding the color map. Besides local raster data, Leafmap also support loading local vector data. So if even some data hosted on the internet, for example, a CSV with coordinates, XY coordinates, you can easily read the data and then convert, for example, to pandas, or you can even directly load the data onto the map. So in this case, I create the map, and then this one called XY data. So basically, you have a CSV hosted somewhere on the internet, and then so that CSV has 2 columns, X and longitude and latitude. And so you just use one line of code, you can load the data to the map just like this. And this is a marker cluster. So you can also, I think I have other example that you can click the marker and then show you some pop-up attributes. Anyway, but besides doing this, you can also click the toolbar icon here, and there's a button here, open. So you can click this one, open, and then, for example, click the CSV, you can actually paste the URL here, and then you can select latitude and longitude and just click apply. So basically, you don't need actually to do any coding. Once you create the interactive map, you can use the toolbar to load all kind of data. It can support vector data, shapefile, Geojson, or any vector data supported by GeoPandas or CSV or GeoTIFF. So basically, you don't need to do coding. You can load the data to the map easily. And I also have a bunch of others that allow you to convert the data type. So we don't have time, but I'll just save some example there if you want to do that later. You can also directly add the Geojson. So in this case, I create the map, and then I have a Geojson hosted on my GitHub account, and just use map.add.geojson, passing the file path, give it a name. And also you can have one, for example, on hover means when I hover my mouse, low right corner here, you can see this one here that it has power attribute. So this one here has an extra space. In Jupyter Notebook, it works fine, but in Jupyter Lab, I'm not sure why it has extra space here. But you can always zoom in and you can see, and then you can click this one to hide it if you don't want to. You can also just close this one. So if you don't need that one. So this is for line. You can also do it, for example, fill in with a random color. So in this case, I have a country GeoJSON, right? You can load the data, one line of code, and then you can hover your mouse. You're able to see something like this. So it makes it really easy for you to load vector data. You also support, for example, shapefile, right? Add SSP, that's it. And then once you load it to the map, you can hover your mouse to see all the attribute. You can also use the open, it's the same, right? Also support KML, GeoPandas, all kind of vector format. So anything that GeoPandas support, any format that GeoPandas support, Leafmap also support. Okay, so, and this is how easy it is to load the data interactively to the map. Besides loading support vector data, it also allow you to download OpenStreetMap data. So in this case, if you're interested in OpenStreetMap data, you can just use the base map, but sometimes you might want to download the original data, right? So if, for example, I want the boundary for the New York City, here, Leafmap give you one other code. So this one here is being downloaded as a GeoJSON and add the GeoJSON to the map. So now you have this data layer, extra data layer to the map, right? So you can turn that one off. This is different from the base map. Now you have access to the original vector data, right? You can source the data by geocode. You can also source by address. You can also search, for example, a bounding box. So there are all kind of things. For example, if you're interested in buildings, you can just what place name you like and what kind of a text. So OpenStreetMap use the text. So you can buildings, restaurants, coffee bar, whatever. You just pass in, and then one line of code, you will be able to download the data to your computer. And then if you want to use that for other processing, you're welcome to. So everything is stored on your computer. And also download from the address, download, for example, from a bounding box. Sometimes if you create a map, and for example, right now I have a bounding box. I want to download all the data. In this case, all the bars within this area, you just one line of code, then you can have access to the data. Again, there are lots of functions here allow you to do that. We don't have time, so I'm just going to skip, but you are welcome to play with that and see if it works for you. And the next one here I'm going to show is the white box. So Leafmap can do all kind of interactive mapping, but it can also do all kinds of geospatial analysis. And it has, let me, looks like some warning. Let me restart my kernel. And so it has a white box integrated, and a white box is a package developed by Professor Zhong Linji in Canada. And I built on top of the white box to provide the interface so that you can use that directly within Leafmap. So what you need to do is to go to the toolbar and then click the second one, second row, click the white box tools. And once you click, it's going to pop up. So as you can see, this one here has 487 tools, and it has a bunch. You can just think about like ArcGIS toolbox, but it's open source. So you can look at the source code. You can directly analyze data directly within the map. So you don't need to do any coding. So for example, LiDAR, hydrological analysis, you're welcome to try it out. So click, and then from here, you should be able to select data from your computer, and then you can pass in the parameter. You can also look at the source code. So just click, it's going to pop up and then go to the website so you can look at the source code if you want. So again, there's a huge toolbox here. You can try it out if you think it might be useful for your research. And so this is a package called Whitebox GUI. I integrated it, and if you don't need the map, you can also directly using this one, Leafmap.whitebox GUI, to open the toolbox. And then, so in this case, right, you can run through the analysis. For example, I can do some simple hydrological analysis. It's going to, for example, smooth the DM, and then also delineate, for example, depressions. So let me quickly show you here the result, right? So original DM, and then you smooth, and then you can do depression filling or breaching, and then you can also do all kind of flow accumulation. It's really fast and really efficient. So I highly recommend that if you are doing geospatial analysis, you might want to try it out. So it's very small and compact. You don't need ArcGIS, you don't need QGIS like to install like huge package. You can just use a browser, and then you can do that in Google Colab, and you can run it in automatic way to save you some time and money. Okay, the last tool here is about creating a link map. So let me show you here. You can just use one line of code, and then they say, I want to create one row, 2 columns in this case, right? So I have 2 maps in here. I'm not sure why it's not showing up here. So once you zoom in and zoom out, it's linked together. So these 2 maps are linked together. And this might be useful if you have some data you want to see side by side, right? So let me show you the other one here, right? 2 base map. You can add multiple data layers if you want. And so next one here, for example, land use, land cover change, right? So this one has 4 years, right? 2001 all the way to 2016. And then you can see this is last figure. So I can zoom in, I can zoom out, and you can just inspect the changes. And if you can see here, it's very easy to create, right? Just one line of code, and then you can customize the layer, you can customize the label. Last one here is about split panel map. So again, one line of code, you can create something like this, and then you can swipe through different data layer, different base map layer, or any other data layers you like. And just one line, you can pass in different base map, and then you can customize the control, what kind of control you want to show on the map, something like this. Okay. And okay, yeah, that's pretty much what I have, and I'm happy to answer any questions. Again, you are welcome to check out the leafmap.org, and I have a bunch of many more examples that I don't have time to show in here, including some more 3D examples. I think I also provide a link here at the top of the Jupyter notebook. You're welcome to check out the Streamlit web app. So this is the one that I recently created. It uses Leafmap and Gmap and a whole bunch of other packages that allow you to create, for example, time lapse and load the data. It has a lot of things that you can play with. For example, you can also directly upload vector data, and then you can doing all kind of mapping directly without having to install anything on a computer. You can also upload data from your local computer and then directly plot the data on the map, and then you can do all kind of customization, sensor data, or even, for example, the US housing market, right? If you want to see how crazy the market it is, you can click the link. And so behind the scene is using Leafmap and Python. There's nothing JavaScript involved here. And it's built up, for example, this is the plotting backend using PyTech. And you can just click one click, you can show it in 3D. Then you can change the color. You can just navigate through, look at like how the median listing price here in the US, and just one click, I can change the color. I can change different scale. For example, this is by county level. I can also do it by state level, right? And you can change different variables here. For example, price reduce count, and you can also change the scale. So to make it 3D. And everything here is just based on open source. So there are a lot of things you can do using this. If you are interested in publish your results as an interactive web app, this might be something you can consider. Again, this is open source. You can click the link here to go to my GitHub repository if you're interested in building some of the app by yourself. Okay, so that's all for my workshop. I'm happy to answer any questions.
Thank you, Qiusheng. So any question from the audience? Qiusheng, I actually wonder, so if is this library also available on PyPy?
Yes, so everything is on PyPI and also Conda. So you can, for example, if you go to the here the repository, and so it's available on PyPI and also Conda. So you can install that directly, just like any traditional Python package.
Okay, great. So it looks like your library is actually, in addition to the map rendering and link to the base map, so you also include lots of geospatial analytics functionalities.
Mm-hmm.
So I just wonder. So if you include those functionalities in your software, actually it will bring in lots of computational overhead.
Mm-hmm.
So probably will slow down the performance. Did you ever consider to use something like GPU to speed up the computation on your like in the back end?
This one actually it does not have any computing overhead. So all the things it provide is the backend, but you can deploy, for example, on Google Colab or Bida or any or AWS or any web services. So it's itself, it does not have any computing functionality. It's just rely on where you want to deploy this one. Where do you want to use it? You can use it on a local computer. You can use it on any web cloud computing environment. So certainly, if your environment already have some GPU capability, right now the package does not have specific things to address the GPU or utilize the GPU. But certainly, that's something that I can consider to incorporate in the future, especially for some other deep learning. This package actually has been adopted by Microsoft Planetary Computer. I'm not sure if it might see So the package has been pre-installed in their Jupyter Hub environment. So if you use this cloud computing environment, you can also use Leafmap directly in there to load the data to analyze some data. So it's if you have access to this one, you will be able to use that.
This is fantastic.
Mm-hmm.
Awesome. All right. Thank you so much for giving this great presentation.